Okay, so we got another thermochemistry problem here. In this case, we're doing a bomb calorimeter. So in this problem, we're burning a 1 gram sample of a rocket fuel called hydrazine, and we're given some information about the temperature that's raised and the heat capacity that's given, and we're supposed to use this to find the heat of combustion for this chemical. So the equation for a bomb calorimeter is Q is equal to C delta T. And this is a little bit different than what you might be used to seeing of MC delta T. So for the bomb calorimeter, we use a capital C, which is still the heat capacity, but it doesn't include the mass. So the mass is already built into this capital C, so you don't need to actually know the mass of anything that's inside the calorimeter other than the fuel. So the unit for this is joules per degree Celsius, and we're given this in the problem. So this would be the capital C value. So don't worry about the mass of the water or whatever is inside the calorimeter. So we want to find Q, which is the energy released from burning this fuel. So the C, we're told, is 5,860 joules per degree Celsius, and the change of temperature, which is final minus initial, so 28.16 minus 24.62, and that's degrees Celsius. And then you can just put this in your calculator, and we'll get out that from burning this 1 gram sample, there is 20,744 joules released. That's a bad comma. So 20,744 joules. Okay, so you might be wondering, well, why didn't we account for the mass? I mean, we only burned 1 gram. Where does that come into account? Well, that comes into account when we're trying to find the heat of combustion per mole. So this is the amount of energy that's released from burning just 1 gram, and we want to find the how much energy is released when 1 entire mole is burned. So let's do a unit conversion here. So this 20,000, what this tells us is 20,744 joules is released from burning 1 gram of this N2H4 chemical. So that's really what we're told, and we want to manipulate our units to get them to kilojoules per mole. Okay, so step 1, let's go from joules to kilojoules. So there's 1,000 joules in 1 kilojoule. So units of joules will cancel, 1 on top and 1 on bottom. Now we're at kilojoules, we now need to get grams to moles. So to do that, we want to use the molar mass. So the molar mass for N2H4, let me see. Okay, there it is, be 32.06. Now, do you put it on top or bottom? Well, we want to cancel the unit on bottom, so we're going to put it on the top. So 32.06 grams of N2H4 per 1 mole of N2H4. So we put it on top because 1 unit on top cancels with 1 unit on bottom. So 1 unit on top, 1 unit on bottom, those cancel. And now we're left with our final unit, which is kilojoules per mole of N2H4. So that's exactly what we want. So from here, you have to put this in your calculator, and you're just gonna, like any other stoichiometry, multiply across the top row and then divide by everything on the bottom row. So you should get negative 665, not negative, 665.1 kilojoules per mole. So that is the heat of combustion for hydrazine.